All right. Good evening or good day. It's currently evening in here, but anyway, right? For your term project, for RefSYST, you will be surprise, writing a term paper. All right. So the summary is just the first part of thermal, the first part of REFSYST strictly deals with the use of refrigerants as working fluids for reversed cycles, right? In topic one, if you guys remember, we did, oh, what refrigerant number is this and that and whatever. And in topics two, three, and four, we dealt with different types of, I don't know, systems, refrigeration systems, vapor compression systems, right? Improvements, what kinds of equipment you're supposed to use when you're accounting for losses, what do you do, stuff like that, right? And by and large, of course, mechanical refrigeration, it is as it is called, right, has dominated the refrigeration industry for a reason, right? It makes sense, right? And we can easily, well, compared to other refrigeration systems, we can easily implement it. However, it would be quite wrong to say that it is the only method of refrigeration available to us. The natural world has granted us with quite a lot to work with. Are refrigerants the be all end all for the HVAC world? You guys answer that, right? The thing is, now you will create a term paper that has you researching about an unconventional method of refrigeration. The second part, right, after ILW, as we go back to class, we'll tackle three non-conventional refrigeration systems which use number one, steam. So how do we make something cold with steam? Number two, air, just air. Number three, heat, of all things. Right? So very interesting. It again would be quite wrong to say that with these four, we exhaust all of our options. There must mean that there is more out there, and indeed, there is. Cole agrees. Hello, Cole. Now, for your term project, you will write an essay that synthesizes information you've gathered about a non-conventional refrigeration system. Your essay will consist of several sections, all of which serve to analyze this refrigeration system in depth. Do not choose more than one refrigeration system, or one type of refrigeration system. Right? Of course, you can choose a refrigeration system which all just hinges on the same kind of action. This will render your submission null and void. So just pick one. Okay? Just pick one. Right, Cole? Okay. First section is introduction, of course. For this section, discuss how the method of refrigeration you've chosen has come to mind. As in, like, how would people think to even invent something like this? Does the main idea come as an offshoot of mechanical refrigeration, right? What kinds of material properties does this method of refrigeration take advantage of, right? How exactly does this method provide refrigeration, or, in the reverse kind, heating? A schematic diagram along with other helpful diagrams such as pH diagrams, HS diagrams, or Molière charts, or TS diagrams must be included in this section. Must be. Okay? Provide a clear path of logic such that a budding engineer such as yourself can understand how you would be able to invent such a method, right? I want you in this section to say that, okay, we know that blah, blah, blah. We also know that la, 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 la. Combine these two methods or combine these two pieces of information together, and boom, you now have the starting idea of your refrigeration system. Also provide a history as to the creation of this refrigeration system. Has someone more archaic tried but failed to enact this method of refrigeration? Or is this a more recent invention made possible by special materials or processes? By that, I mean, I don't know, did Da Vinci try this out before? I don't know, right? Or maybe is this like some really special, really fringe case of refrigeration wherein, I don't know, it seems very stereotypical, but like, I don't know, people in Europe or in Japan have cracked the code. They've managed to get refrigeration out of, I don't know, concrete. I don't know, something like that, right? Next section, we will have computations in the COP. For this section, discuss all the computations necessary to analyze your chosen refrigeration system. Most important to this section is the computation of the COP, which tells us what we need to know about the performance of the system. Kaya nga, coefficient of performance. First, provide the necessary formulas to compute values required to analyze this method of refrigeration. This may be as simple as an enthalpy change if you're using a fluid, which Isn't that just mechanical refrigeration? Or maybe it's as complicated as formulas related to electromagnetism. Maybe, right? And that's already kind of a hint as to like maybe what you can write or what you can research. And then the important detail here is that you're able to attribute where the heat transfer is coming from or what exactly causes the refrigeration or the heating. Then comment on the usual ranges of the values. Is it like, I don't know, hundreds of kilojoules, or maybe it's just tens of nanojoules, maybe something like that. Right? In other words, specifies if the system is designed to be for micro or macro applications. Is it just for us, or maybe it's for ants? I don't know. Finally, discuss if the coefficient of performance is actually accurate in this case. Because, spoiler alert, sometimes it's not. Right? We will actually talk about how it's not in our last topic. Yeah, I believe. But yeah, just try and think, right, about the efficacy if a COP really is the correct way to estimate the performance of the system. Right? If a more accurate metric is available, then you tell me. Right? Then you tell me. Okay, now section 3. Of course, we have to compare it with mechanical refrigeration. Okay, of course, it's impossible to just say that like, oh, this refrigeration system is good compared to what, right? You need to compare it with what we currently use, and of course, what we currently use is mechanical refrigeration with refrigerants. Right? Be wide in your comparison. Account not only for the quantifiable aspects like the amount of heat removed, the amount of power necessary to perform such refrigeration, but for other things like, say, for example, cost. Right? Refrigerants cost something. Electricity costs something. Maybe you want to account for that. Maybe your new refrigeration system, it's just like, I don't know, you inhale something, you exhale it, and then wow, it's free. I don't know. Right? Maybe you can also think about it like, oh, it's more advantageous in systems where you don't have electricity. Application. Maybe it's better for off-grid applications. And maybe scale. You don't need refrigerants for very small things. I don't know. To be clear, you're not advocating for your method of refrigeration, huh? If you conclude that, oh, this sucks, that does not mean you have a bad grade, okay? Concluding that this method is more costly, injurious, and less effective does not warrant a low grade. However, if you try and mess with the statistics, mess with the numbers themselves, falsely concluding that this method is superior to mechanical refrigeration by omission of facts and manipulating data, will give you a low grade. Okay? And lastly, challenges and innovations. Of course, we're patterning this like a normal, what do you call this? A normal research-ish paper, right? For this section, you'll talk about what the future is for this refrigeration system, right? Where will it go? Are there any challenges that try to hinder its development? Or, well, is it a mature technology already? You may have already provided this in the previous section, but the disadvantage of your method of refrigeration may be that it is just unfinished. It needs more research, right? Compared to the mature yet innovative technology of refrigerants. We're making more stuff, right? Based on the Montreal Protocol, they were like, you know what? CFC's gone, right? HFC's, I don't know, right? So we're trying to create more blends of refrigerants. We're trying to create refrigerants that don't make a hole in the ozone, that kind of stuff. Right? This section should contain what's next for your chosen method of refrigeration. Maybe a new process is being developed. Maybe a new material is being developed. Maybe, I don't know, it really is just this, right? Conversely, if current scientific consensus dictates that this is as far as we go for now without significant scientific discoveries elsewhere, let's say, for example, a room temperature superconductor. As of the posting of this video, it's not yet here, right? Do not hesitate to document this as well. Again, if your method of refrigeration sucks, it does not mean that your paper sucks, right? Your paper is only going to suck if you lie or you don't do enough research. Okay? This section also serves as the conclusion for their paper. Use this to synthesize the information you've gathered through your research and provide a succinct but truthful summary of what you've learned and where the refrigeration system can be used. And now for the requirements, right? Of course, I need you guys to exert some effort into this term project, right? It is a significant portion of your grade. Therefore, the essay must consist of at least 2,000 words. Pictures are allowed. You don't need to put table 1, figure 1. Don't worry about that. You can go bananas, right? And please do not put a title page, huh? I do not want to see the DLSU logo and then in partial fulfillment of. Don't bother about that. Okay? Just have your name, your ID number, your section, enough. Right? That's it. Document details are as follows. It should be on short-sized paper, letter size 8.5 by 11. The margins should be half an inch on all sides. The paper should be stapled. The font size is 12. Line spacing is 1.5, not just the normal 1.15 that we know. Font style is any serif font. Serif font is the fancy font. If you don't know what a serif font is, it is the left side, right? The serif basically is the little swishes that you have at the ends of your letters, right? So I want this to be somewhat professional, refined, right? And the text should be justified, okay? And if you're going to have citations, and of course you're going to have citations, this is research you're doing, it should follow the most recent APA edition, okay? Not following these instructions results in a -3 for every bullet point not followed. Improper citations, hallucinations for DOI links, and the like will receive harsher deductions. So say, for example, you didn't follow these 3, that's already a -9. Okay? The goal of this project is for you yourself to look into the future of refrigeration through newer, more unconventional systems. While I'm not restricting the use of LLMs as a tool to gather and synthesize information for your essay, I'm restricting the use of LLMs in writing the paper. That means you will write the paper, not ChatGPT, not Gemini. You will write the paper. Maybe you can ask them to outline things for you, but still, you're going to have to write the paper. I would like to see your own writing style shine through. You've seen how I write. You've seen this document. You've seen my quizzes. That is how I write. I would like to see how you write. I would like to see your thoughts be put to paper by yourself, even if you think it doesn't sound as verbose or as well-spoken as you would like it to be. If you're very conscious about your grammar, you come from a school or you come from a background wherein, well, this is just not, how should I say this? This is not made the focus of your education. I understand, right? So I'm allowing the use of tools like Grammarly just to improve your grammar, but I still want to see your style come through. Okay, but please declare if you're using any such things to augment your writing style. Okay, if I see lots of M dashes, although I do use M dashes myself, or any kind of behavior that makes it seem like it was written by ChatGPT or by Gemini or all of those other LLMs, I will take it against you. Okay? The deadline for this project is on November 29th, Saturday. That means you will have 4 weeks, 10 p.m. There will be no extensions. The highest possible score will decrease by 10% for every 24 hours that pass after the deadline. If you're going to submit to me 10:01, your score or highest possible score will only be 90%. You must submit the paper as a printed hard copy submission. For the people who raised their eyebrows when they heard stapled, yes, you're gonna have to print this out. Okay? So it doesn't matter if it's colored or if it's black or white, doesn't matter. Just print it and hand it to me. There are 2 possible ways of submitting this document. Either you can submit it to me in class, right? We're going to meet Tuesdays 4:15 to 5:45. You can submit it to me before or after class, or whenever you meet me in campus. Or number 2, you can submit the document indirectly through a box that is near the table outside the Department of Mechanical Engineering. You guys are 1, 2, 3s or older. So, I suppose you already know this, but the DME is in Brother Andrew Gonzalez Hall, 8th floor. If you're coming out of the student elevators, turn right. Online submissions through Canvas or any other means like email or Messenger will not be accepted. Okay? I want your hard copy submissions. And that means also that after I've read through and after I've graded your paper, I will return it to you. Whenever, right? Maybe finals, maybe if you're submitting early, I will give it back to you in class. Okay, early submissions will be incentivized. Congratulations. Submissions made on week 10, it is currently November 1, and that is week 9, will warrant a plus 15 quiz score. Submissions made on week 11 will warrant a plus 10 quiz score. Submissions made on week 12 will warrant a plus 5 quiz score. And submissions on week 13 will get nothing. Okay, you just submit. Okay. And the criteria for grading, you can, of course, read through this for yourself, right? I've uploaded the copy of the document of the primer here in our modules tab. But what I want is content, of course, 40%, accuracy and critical thinking for the advantages and disadvantages, another 40%, and grammar and cohesion, right? What I want is a very comprehensive kind of state, if you want to think about it, a literature review for the refrigeration system you have mentioned, right? I want the graphics in your paper, the details in your paper to paint a clear picture of, okay, this is how it works, this is how it's done, right? Of course, in your last section, of course, you're going to also put in here what the feature of the refrigeration system is going to be. That needs to be also very clear, right? And in the accuracy portion, of course, all of the data that you need to that you have to state should be accurate, right? It should be very clear as well, right? Be smart in how you're presenting this data. This thermodynamic and scientific principles also need to be accurate, of course. And here, please exercise critical thinking in your advantages and disadvantages, right? It's not just, it's more expensive, right? It's much more than that, right? Let's try to be let's try to think about things as multimodally as possible, right? Think about the different kinds of sectors or whatever that you can think of, right? That would make it a bit more fair, or would present a fairer image for your refrigeration system. And of course, you guys are college students. I want the paper to be appropriately written, right? I want your word choices to mirror the fact that you are college students and you're not just, I don't know, high school students, right? And the pacing, of course, this is going to be an essay, so needs to have a start, middle, and an end. And the grammar should not make me do a double take, like, huh? Right? Of course, if you have a little mistake in grammar, that's completely fine, right? If I understand what you're trying to say, I won't mind it. But if it makes me stop and makes me read what you just wrote, I feel like something has gone wrong. Okay? And so that's it. That's our, I know, that's your project, right? This is just a little term paper, right? It's just a little paper about what other kinds of refrigeration are out there. Again, blacklist, right? Blacklist steam jet refrigeration systems, air cycle refrigeration systems, and absorption refrigeration systems. Okay, you cannot use these three because I will be the one to discuss this. Okay, that's it. Thank you very much. I will see you next time. Thank you.